In the previous video, we determined the empirical formula and chemical formula for an ionic compound. In this video, we do the same for a molecular compound. Typical problem that we might come across for molecular compounds in determining the empirical formulas and chemical formulas is this one here. 8.60 grams of a hydrocarbon sample contains 7.11 grams of carbon and 1.49 grams of hydrogen. And we're being asked to determine the empirical formula and then the chemical formula using the additional information that the molecular mass of the compound is 58.12 atomic mass units. The way we're going to tackle this problem is we're going to determine the empirical formula first, and then we are going to use the molecular mass data to work out what the actual chemical formula is. We can write down the empirical formula, CXHY, where X and Y are the whole number subscripts in the empirical formula. And I should just point out that for hydrocarbons, the carbon is always written first and the hydrogen is written last. The X and the Y represent the mole ratio of carbon and hydrogen in this compound. And as I said, we need to find out what those values of X and Y are as whole numbers. This particular problem gives us the mass straight away, as opposed to in the previous video where we had mass percentage data. So our 8.60 hydrocarbon sample contains 7.1 grams of carbon and 1.49 grams of hydrogen, which means that we can use our molar mass equation to work out directly the moles of carbon and the moles of hydrogen in this 8.60 gram sample. So moles equals mass on molar mass. We can do that for carbon first. The mass is 7.11 grams and the molar mass 12.01 grams. And remember, we just read that directly from the periodic table. So the moles of carbon end up being 0.592 moles of carbon in that 8.60 gram sample. The moles of hydrogen, we do the same. Mass over molar mass, we got 1.49 grams as the mass. We got the molar mass 1.008 grams per mole. And again, we read that directly from the periodic table. 1.008 is the molar mass to 4 significant figures for hydrogen. Put that into our calculator and we get 1.48 moles. So that 0.592 moles is essentially the moles of carbon and the 1.48 is the moles of hydrogen. And these could effectively be the mole ratios, and we could write down our empirical formula like this. But we know that empirical formulas need to have whole number subscripts, and so the easiest way of getting these numbers into whole numbers is to find the moles that has the lowest amount of the two. 0.592 is smaller than 1.48, and we divide each of these mole values by the smallest mole value. So 0.592 divided by 0.592 and 1.48 divided by 0.592, and 0.592 divided by itself is 1. 1.48 divided by 0.592 is 2.5. So whilst we've got the carbon as a whole number, we've still got the hydrogen not as a whole number. We've got a ratio carbon to hydrogen of 1 to 2.5, and the simplest way to make this a whole number ratio is to just multiply both of those subscripts by 2, so that we get C2H5 being the empirical formula for this compound. And it's an empirical formula for a molecular compound. Remember, molecular compounds just contain nonmetals bound with nonmetals, the carbon and the hydrogen being both nonmetals. It's also worth pointing out at this point that the molecule C2H5 does not actually exist, and that this is not the chemical formula of a compound, it's the empirical formula, the lowest whole number ratio of a compound. And the actual molecular formula, as we've said before, will be a whole number multiple of the subscripts in the empirical formula. So we can write the empirical formula down on the left-hand side there, C2H5, and we can use some new subscripts now for the actual chemical formula. So CaHb, what are the actual values of A and B? They are going to be whole number ratios of 2 and 5. How do we determine exactly what they are? Well, we know that the molecular mass of the compound is 58.12 atomic mass units. Now, if we were to look at the molecular mass for the empirical compound, C2H5, 2 times the atomic mass for carbon plus 5 times the atomic mass for hydrogen is 29.06 atomic mass units, and the ratio between these two values is 2. So when we're trying to determine the actual chemical formula of this compound, we're going to take the subscripts in the empirical formula, and in this case we're going to multiply them by 2. And so what we're ending up with here is the compound C4H10, and this is the chemical formula for the compound provided in this question here.